two masses are connected by a pulley and we're trying to find the acceleration of the whole system. So we know force equals mass times acceleration. We could play around with that formula and we could get that acceleration is equal to force divided by mass. Well, net force. Because this is net force. And then, so if we draw a free body diagram for the mass 2, it's just force of gravity. And if we draw a free body diagram for mass 1, we have to draw it tilted because it's on an incline, with an angle. So the question asks us to find the acceleration of the whole system. It gives us a mass of 6 kilograms and another mass of 5 kilograms, and they're connected by a pulley. So we know the formula to find force is mass times acceleration, but we can play around with that and we'd get accelerations equal to force divided by mass, and it's net force actually. So we'd have to draw the force diagram, free body diagrams for both of the objects, and this for mass 2 would just be gravity, and for mass 1 it's on an incline, so you have to draw the force body diagram tilted. So if we finish the rest of this force diagram, you see that Fgx always goes down, and the force of gravity is equal to the mass times gravity, so it would be 50 here, and for mass 2 it would be 60. And we have to solve for the components, so I drew another triangle. The angle is always between Fg and Fgy, so this time Fgx would be opposite and Fgy would be adjacent. So sine of 50 sine of 30 is equal to x, and 50 cos of 30 equals x. So you get 25 here, and you get 43.3 here if you plug it into your calculator. So we have the values of our components. So here we know that Fn cancels out with Fgy, and so Fgx would be the net force for the object on the incline, and gravity would be the net force for M2. And we can assume the accelerations in this direction, since M2 has a greater mass than M1, so it would kind of be like pulling it this way. So back to the A equals F net over M formula. So we'd end up doing 60 minus the Fgx we solved for, which was 25. My bad. Over the mass, but since we're looking for acceleration in the whole system, we have to take the mass of the whole system, which would be 11. And then if you do 60 minus 25 divided by 11, you should get that the acceleration is equal to 3.18. How would this problem change if we added friction? So we'd end up having Fgx and friction. And in order to solve for friction is fun. We already solved for the components of the Fgy and Fgx from the previous part of the video. And so you would do the normal force is equal to Fgy because they balance out. It's the mass one's only moving horizontally. And you'd get 8.66 for your force of friction. And then to find the acceleration's F net over the total mass. So it's Fg minus Fgx minus F force of friction. And you'll end up getting 2.39. So in order to find and finish up the last step, which is to find tension. You draw a force body diagram of the 6 kilogram block. So the force of gravity is going to equal 60. And the force of tension, we don't know. That force is equal to MA. We would try to find the net force in order to solve for tension. So we already technically know the net force because we can plug in the mass, 6, and then the acceleration we solved for, which will be the same throughout since like the pulley has no mass or anything. And then, so the force of gravity is 60, so 60 minus t is equal to 6, the mass, times the acceleration, and you get tension equals 45.66.